When we do sighting, you want to have the elbows locked at all time, because if I am measuring and I get the dimension and then I bend my elbow, all of a sudden this getting closer to me, the skewer is going to appear much larger than the dimension that I took, because it's getting closer to me. Okay, so always elbow locked. Don't tip the skewer, because if that's the dimension that I locked in my subject, as I tip the skewer away from me, the skewer gets shorter. Now it's like half the size of that subject. Okay, so if you tip the skewer, the subject is going to get bigger. If you bend the elbow, the subject is going to get smaller. The subject didn't change at all. It's the perception of the skewer compared to the subject that changed. Okay, so elbow locked and skewer perpendicular. Okay? Close one eye, and then you can measure, we say scan horizontal, scan for verticals, clocking angles. Okay, that's all useful. And the important one is managing relationship of proportion. So, and I'll show you here on the subject actually. Okay. Hi everybody, today we will talk about sighting, specifically about clocking angles. The subject is there in position for us, is an simplification in boxes of the torso of the human body. So the rib cage being on the top and the pelvis at the bottom. You also see the sternum and the indication to the 10th rib here. I have a skewer in my left hand. I like to use my left hand so I can keep drawing with my right. But it's pretty straightforward. So if you get the skewer vertical is at 12 o'clock, horizontal is at 3 o'clock, and anything in between. So for instance, this angle, I close one eye and I line up the skewer, and I can see that is not vertical. It is not 11 o'clock though. 11 o'clock will be more right there. So we can arguably say that's like 11:45. Okay, this angle is a little steeper. We have to account for perspective. So it's going to the same vanishing point as the US one. So it's a little more towards 12 o'clock. And vice versa, this one, it's also going to the vanishing point that this one is going. And so that one will be a little less than 11:45. Okay, so between the three of them, they're all going towards the 11:40 mark. Okay, let's look at these bottoms. This one feels horizontal, it is horizontal, and so is that one. And so is that one. Now, because I see this side of the box, I know that those lines cannot be horizontal and that they will go to a vanishing point far out this way. So if I have to make a mistake, I want to make it towards the idea being here that I have to take care of this perspective, this 3-point perspective. So those lines, I can angle them like this. That would be a better mistake than the opposite, that angling them like this. Okay, because I see this plane of the cube, so that means that my vanishing point on that one is going to be on that side. Okay, in this Illustrator rendering, I show you where the vanishing points are. 3 different colors for the 3 different vanishing points. In this slide, you really get an understanding or the distance of the vanishing point from the subject. It is well way beyond the paper, so going intuitive is a much better choice. This is closer to me, that's further away from me. Let's check the sternum angle. It's going to be an angle that's right in between this one and that one. So you can put it there, and then go on your imaginary clock and think like, well, somewhere close to 12, but it's not 12 o'clock, and it's not at 11 o'clock. Let's look at the sternum to 10th rib. It's about at 10 o'clock. The other one, it's about 1:30. Let's check those lines. You see how I have to change the skewer. Really gives you a sense of the vanishing point. The vanishing point for those two lines is visible. I'm going to see if I can point it out. a little higher. There you go. Okay. Okay, besides clocking the angles, the other thing we can do with the skewer, we can check for horizontals and verticals. Okay. So let's scan them for horizontal. It shows you which corners start touching first, then this one, and we go down. The right one is higher than on my left one, and then the right back, then the left back. Keep it horizontal. Right back for the bottom, and then left. Right, left, left, right here, or here we do horizontal because I have to account for the vanishing point again. Okay, so last thing, okay, you can do verticals as well. So it's surprising, look at the alignment, that point and this point, they're pretty much on a vertical line. Let's see back here if we get surprises. That's the most external point. Yeah, this top one lines up almost with the bottom edge. Okay, so very useful checking for vertical and horizontal. Oftentimes you will see that you make mistake, as in you check your subject is at 11:45, you go on your drawing, it is at 12:05. Okay, so I change subject. I have now the skewer is in focus and my balls are out of focus, but when you are looking at to real life, they're both in focus. Our eyes are much stronger, much more sophisticated tool than this camera. So let's check then. That's the width of the vessel compared to the width of the other ball. We see that the width of the other ball is slightly bigger. What about compared to its height? No. What about compared to the height of what about the height of this vessel compared to the width of the ball? That's about the same. So what we look for at the end is relationships, and I'm trying to keep them as close as possible. The ball is a little smaller in diameter, and you can account for that. Okay. What about the width of the vessel compared to its height? Well, it's about 3/4. Okay, so you take for relationships with the skewer. You don't measure that and then you go on your paper and you make a drawing that's going to end up being that small. No, we're checking what about the height of this vessel with the width of the composition. I cannot put 1 3/4. Okay, that's obviously horizontal. What could be, what if we do then we will have 1 and 2, right? 1 and 2 composition wise. Let's put this back in focus. So again, we are studying relationships.